So we have a new situation. So this time we have steel reinforcements both in the tension and compression side of the concrete. Determine the following crack transform moment of inertia of the section. We have to identify which side is the tension side. So is it the upper side or the bottom side? Whichever has the larger amount of reinforcement, so that corresponds to the tension side. So meaning in this case, our bottom is the tension side and then the upper side is the compression. So meaning, when we say crack transform moment of inertia, we will no longer include the concrete below the neutral axis. So let's start. So again, we should locate the neutral axis. We take the moment of the elements above the neutral axis towards the neutral axis. And we equate that to the moment of the elements below the neutral axis towards the neutral axis. First is the rectangle. So that is B sub y times y over 2. Next, the area of the steel reinforcement. So we call that as AS prime. And then we multiply that by 2n minus 1. Okay, so what's the reason behind 2n minus 1? Previously, we only use n as a multiplier to AS when taking moments of the A sub S. But this time, we have 2n. It is because, according to the study, the steel reinforcement on the compression side is stronger than the reinforcement on the tension side. That is why we are multiplying the modular ratio of the compression reinforcement by 2. So meaning it is stronger by twice of the amount of the strength of the tension reinforcement. That is why we have a multiplier of 2. And then we have minus 1 again to account for the effect of the displaced concrete. O yung tinatawag na butas, no? Kasi nga, wala naman talagang concrete dito. But we have considered the concrete as a whole, so we need to subtract it back. So that is why we have a minus 1. Times, how far is the centroid of this reinforcement towards the neutral axis? That is y sub t minus d prime. So d prime, by the way, is the distance from the compression reinforcement to the concrete fiber in compression. Okay? And then the moment at the other side of the neutral axis or in the bottom side of the neutral axis, that is AS times N times D minus Y. Okay, so we substitute the values. 250 times Y over 2 plus AS prime. So we have 225 millimeter diameter. So the area is 2 pi over 4 times 25 squared times 2n minus 1. So take note, n is 8.04. So minus 1 times y sub t minus 65 equals 3 pi over 4 times 25 squared times 8.04 times 435 minus y sub t. 138.9. Next, we can now compute for the moment of inertia. So again, moment of inertia of the rectangle with respect to the neutral axis is 1/3 dy cubed plus A sub S times N. This is the moment of inertia of the tensile reinforcement times D minus Y sub T squared plus AS prime times 2N minus 1 times Y sub T minus D prime squared. Okay, so let's substitute the value. We already have our moment of inertia, so we can now start solving for the stresses. Maximum compressive stress times C over I lang din. That is 72 times 10 to the 6. So our y is 138 divided by our moment of inertia. So that is 7.45 megapascal. So that is letter D. Stress in tension steel. So anong formula natin? Ganun pa din, MC over I. So distance from the neutral axis towards the tensile steel. Be careful, we have two steel, compression and tension. So, tension steel ang tinatanong. So, that is D minus Y sub T over moment of inertia. So, we have to convert to the steel. So, that is I over N. Fs equals 127.70 megapascals. Stress in compression steel. So that is M, then Y sub T minus D prime over I over 2N. Be careful sa modular ratio, no? Kapag tension steel, N. Kapag compression steel, naka 2N tayo. That is letter C.